Hello everybody and welcome to today's lecture about faults and network availability. So these faults and the availability of a network can be arranged and assigned to the network structure, protection and operations of a network. So it is about the network availability, that means the reliability of supply. First, let's start with the fundamentals of probability calculations. It must be kept in mind that probability is not certainty, it is a measure of likelihood, it is a theoretical limit value, and it is given, according to this law, by the limit of the frequency of an occurrence divided by the total events that are observed. So the AND law, as it is called, is applied if the event that we are looking for consists of two sub-events that must appear at the same times, and if these events are non-exclusive, then the product of P1 times P2 gives the probability of the occurrence that both events occur at the same time. In contrast to this, we have the OR condition. That means if something happens or the other happens, then it is counted as one event. So for this, we have, if these are exclusive, the sum of the two probabilities, and that is the OR event. If the two events are complementary, P of the complementary event is 1 minus P1. The OR condition can be modified if the two events are not exclusive. That means they may happen at the same time, they may not happen at the same time. Then the probability is given as the sum of the single probabilities minus the product. In technical reality, since these probabilities of failures, that is what we speak about, is so small that the product of small entities is so small that it more or less can be neglected. So let's see what is the operation diagram of a system. A system is an operation that is the up state, and sometimes it breaks down as indicated in red circles, and this is the downtime. And the non-availability is given by the total outage time divided by the whole observation time. By a little mathematical trick, I would call this, dividing and multiplying by the same quantity, that is n, we can see and rearrange that n divided by the total observation time is the frequency, and that is multiplied with the average outage time. So we come finally to the law of non-availability. Non-availability is the product of frequency and average outage time. The application to electric circuits means that we have series connections and parallel connections. Let's look at the series connections. So the failure of a system, if one of these elements fails, either the line fails or the transformer, that means there is no electricity to the observation point. So the series connection is given as the sum of the single failure probabilities. In contrast of that, in order to apply the n-1 principle, we double, for example, lines, as is indicated here. And the system now fails if both lines 1 and 2 fail. That is, the product is the relevant quantity of the failure of these two parallel entities, parallel lines. So now finally let's apply this to an example of a semi-redundant network, and I go on step by step. So the network can be seen here. It is a overlying grid, for example 110 kV grid, two parallel lines, and in series to this one transformer. It is semi-redundant because it is redundant concerning the lines, we have two of them. It is non-redundant concerning that transformer. On the left side of each element you can see the average frequency and the average outage time. And now we start with to determine the frequency and the non-availability at the observation point, that is the consumer at the end of this line. So the superimposed grid is given by this basic formula. Non-availability is the product of frequency of occurrence of faults and the average outage time. And this is 1 divided by 30 times 5. And the unit is important. It is hour divided by year. So the number here is the non-availability is 0.167 hours per year. The next step is to determine the non-availability of the parallel feeders. So we have the non-availability feeders and start with the non-availability of feeder 1, which is given by the average frequency 0.20 per year and the average time. So the non-availability of such one feeder comes out as 9.6 hours per year, and for a very specific reason I turn this into a per unit expression. That means I convert the 1 year into 8,760 hours divided and arrive at a non-availability of 0.011. The reason why I do this is we have to multiply the non-availability of line 1 with the non-availability of line 2, and that is very conveniently done by multiplying these per unit quantities. And the per unit quantities, by the way, can be reversed into hours per year by multiplying with this factor of 1, which is 8,760 hours divided by 1 year. So the element number 3 in the sequence is the transformer, which just is obtained by the frequency times the average outage time, and this has a non-availability of 0.048 hours per year. The total non-availability of these serial elements is given by the sum, and that comes out as 0.183 hours per year. And in other terms, the year can be again expressed in 8,760 hours, and it comes out in per unit. And how about the availability, which is 1 minus the non-availability? It is given, as we can see here, as 0.99979 per unit. And if this is expressed in percent, we can see that the grid is available for 99.997% of the observation time of 1 year. So that means it is highly reliable. So this was today's chapter about faults and network availability, or the reliability of supply. Thank you very much.